Deep beneath the surface of classical logic lies a realm where particles exist in a state of suspended animation, occupying multiple positions simultaneously. This is the world of quantum mechanics, a domain that defies our everyday intuition. In the 1920s, pioneers like Heisenberg and Schrödinger unraveled a reality governed not by certainty, but by probability clouds. It is here that we find the foundational architecture of the universe, suggesting that at the smallest scale, existence is not solid, but fluid and purely mathematical. As we delve deeper, we encounter the principle of superposition, the strange phenomenon where a quantum system can exist in all possible states until it is observed. The act of measurement itself forces the universe to collapse from a spectrum of infinite potential into a single, concrete reality. This suggests a participatory universe where the observer is inextricably linked to the observed. We aren't just looking at the world, we are, in a fundamental sense, defining it through the very process of perception. The mystery intensifies when we introduce quantum entanglement, what Einstein famously dubbed spooky action at a distance. When two particles become entangled, they share a singular existence, regardless of the space separating them. If you change the state of one, its partner instantly reacts, even if it is on the other side of the galaxy. This defies the cosmic speed limit of light, hinting that space itself might be an emergent property rather than a fundamental constraint, acting as a mere projection of deeper data. This leads us to the bold hypothesis of the digital universe. If reality is composed of discrete packets of information, quanta, rather than continuous matter, then the universe functions remarkably like a computer program. Just as a digital image is made of pixels that look smooth from a distance, our world may be constructed from Planck-length information bits. If our reality is computable, it follows the logic of algorithms, processing data to generate the illusion of physical space and time. Consider the holographic principle, a radical theory originating from the study of black holes. Physicists have discovered that all the information of an object falling into a black hole is stored on its two-dimensional event horizon. If this holds true for the universe as a whole, it implies that our 3D reality is merely a projection, a complex, vibrant hologram rendered from information encoded on the flat boundary of the cosmos. Everything we touch, see, and experience could be the result of a vast, informational surface. This paradigm shift forces us to re-examine the role of complexity in the universe. If the cosmos is essentially an information processing machine, then consciousness might be the inevitable byproduct of that calculation. As systems grow more complex, they begin to simulate the environment around them. We are essentially self-aware algorithms, capable of analyzing our own source code. The deeper we dig into quantum gravity, the more we find that the hardware of the universe is made of math. Yet, if we are part of an advanced computational structure, we must ask, who or what is the architect? This brings us to the fringe of modern physics, where some theorists argue that the universe may be a self-simulating feedback loop. By studying the laws of physics, we are essentially performing a system diagnostic on our own reality. The fact that the universe operates on elegant, universal constants might not be an accident, but a necessity for the stability of the simulation itself. Ultimately, the quantum journey leads us back to ourselves. Whether we live in a base reality or an exquisite, layered construct, the truth remains that we are part of a grand, informational unfolding. The search for the ultimate theory of everything is not just a quest for equations, it is a quest for self-discovery. By unraveling the quantum paradox, we are finally learning how to read the language of the creators, peering behind the veil of the material world to see the infinite code beneath.